Now that we've gone through the structure, functionality, key methods, and example applications for Java Countdown Latch, Java Cyclic Barrier, and Java Phaser, let's take a step back and talk about some of the usage considerations for applying these Java barrier synchronizations in practice. Java's barrier synchronizers can be used for a number of different purposes. Countdown Latch focuses on events and actions. For example, it can be used as an on-off latch for an entry barrier. Going back to our earlier example of video rendering and a video rendering engine, various threads that are doing the rendering can invoke a wait to block at the latch until the main thread invokes countdown to let them start up and do the processing. So that's a good example of an entry barrier. Countdown Latch can also be used for more sophisticated exit barrier use cases, as exemplified with our tour guide example we talked about. For example, you can have one thread that waits until n threads have completed an action, which might be the case where the tour guide waits for n tourists in a museum to finish and exit before shutting the museum down. Likewise, one thread can wait until some action has completed n times. So as we saw before, we can have one thread that waits for n things to happen, and you can count them down either in one thread or in different threads. For example, the main thread waits until the worker threads are finished rendering the video before it continues with the next phase of whatever it needs to do. Cyclic barriers focus on threads. In particular, it enables a set of threads, which it calls parties for some odd reason, to all wait for each other to reach a common barrier point, such as an assembly line where cars go by, groups of workers, a fixed group of workers works on the cars as each one goes by. Once they're done with their pass, they then let the car go to the next element in the line. For example, you can use cyclic barriers to complete the processing of one or more algorithm iterations. For example, we talked earlier when we talked about the Java cyclic barrier example application that it would run the various GCD tests for the various algorithms in phases. It would let all the algorithms run on one set of data. Then it would generate the next set of data. It would then let all those algorithms run again and time their performance and so on. Remember that cyclic barrier requires a fixed number of threads, which is really one of the limitations that it has. So as a result, if you need dynamic parties, dynamic thread support, you need to focus on a different barrier synchronizer. That, of course, is what motivates phasers. They enable a variable or fixed number of threads to wait for each other to complete processing in cycles or also in a one-shot phase as well. So in a sense, they're more flexible than the other two Java barrier synchronizers because they essentially subsume them and what they do. However, they're also a bit more complex to program because they have a lot more features, and you have to understand more nuances with respect to how the various threads interact and how threads can join and register and arrive and advance and so on. So they're a bit more complicated to use. So for the simple use cases, I recommend sticking with cyclic barriers or countdown latches. They're much more popular, much more common because they solve sort of the usual case. So that's the end of our discussion about Java barrier synchronizers and the usage considerations therein.